Hi all, in this video we are going to see aggregate aberration value test. It's based on Essex BTech Transportation Engineering Lab prepared by Dilruba KM. Okay, so what is aggregate aberration value? Aberration means it is the property of aggregate which undergo wear and tear due to the movement of traffic on the road. So when vehicles move on the road, soil particles present between the tires and the road surface cause abrasion of road aggregate. And in this test, we use steel balls in order to create the same amount of wear and tear that may occur in our road surface. So even in the absence of pneumatic tires, in Indian scenario, we know steel-rimmed wheels of animal-drawn vehicles are also using the same pavement. So these steel-rimmed wheels also consider abrasion on road surface. And therefore, the road aggregate should be hard enough to resist these kind of abrasion. So in this test, Los Angeles aberration value test, we are testing whether the aggregate which we are going to use in the field is resistant enough to face these kind of aberrations. So the principle behind this test is to produce abrasive action by use of standard steel balls which when mixed with the aggregate and rotated in a drum for specific number of revolution, it also causes wear and tear which is similar to that of road surface. Okay, so let's see what are the required apparatus. We need 4 sieves, IS sieves, 1.7, 10 mm, 12.5 mm and 20 mm IS sieves, and some amount of steel balls or cast iron balls. Then a oven for drying the aggregates, a tray for collecting the aggregates, and a balance for weighing the aggregate. And obviously the aberration testing machine, that is Los Angeles aberration testing machine. So this is the testing machine. We will feed this aggregate into the testing machine by removing this cover. So let's see the steps. The first step is to fix the gradation. So here is a table which is provided you with different number of gradations. Gradations are A, B, C, D, E, F and G. So let us say I'm taking the gradation B. Then for the gradation B, you have to take 2500 grams of aggregate which is passing through 20 mm and retain on 12.5 mm, and 2500 gram aggregate which is passing through 12.5 mm and retain on 10 mm. Okay, so we will collect total 5 kilogram or 5000 gram of aggregate passing through 20 to 12.5 and 12.5 to 10. Say if we are taking the gradation D, then what we will do is we will collect the aggregate which of 5000 gram which is passing through 4.75 mm and retain on 2.36 mm. So this is a standardized table which provide you the amount of aggregate to be collected for each gradation. Okay. So in this test we are going to take the gradation B. Next, as we have selected the gradation B, we will collect 2.5 kilogram or 2500 gram of aggregate passing through 20 mm and retain on 12.5 and 2.5 kilogram of aggregate passing through 12.5 mm and retain on 10 mm. So we have total of 5 kilogram of aggregates. Second step is to select the number of steel bars according to the below table. So here I told you we are taking grading number 2, B gradation. So for B gradation we need 11 number of steel balls. If it was A, we may require 12 number of steel balls whose weight was 5000 plus or minus 25. So here we are taking B gradation. So we may require 11 number of steel balls whose weight is 4584 plus or minus 25. Okay. And fourth step is to feed this aggregate and steel balls into the aggregate aberration testing machine. So we will put this aggregate along with the steel 11 number of steel balls into the testing machine. Then after that you must make sure you close or you place the cover and tighten it perfectly, because we are going to rotate this instrument. So if the cover is not tightly fixed, this may come out and we may not be able to find out the aberration value. Okay, so what we will do is we will fix it on this cover should be fixed on the equipment. Next step is to fix the number of revolution. Here we are taking 1000 number of revolution. So here you can see a numbers. So we will reset and place it on 1000. Keep it set it for 1000 number of revolutions. Okay, this one you can see in the side of this machine. Here we will be keeping our revolution. So we are keeping a revolution as 1000 and on the button, then the machine will start rotating. And in the sixth step, we will stop the machine after 1000 number of revolutions. The revolution should be given such a way that for per minute 30 to 33 time revolutions will be occurring. So you can calculate how much time does it take to complete 1000 number of revolution. Definitely when we set the number of revolution, the machine will stop after 1000 number of revolution. So after stopping the machine, we will remove the cover and collect the aggregates and the steel balls by keeping a tray below this machine. Now we will separate the steel balls from the aggregate and sieve it through IS sieve 1.75 mm. And now we will find out the weight of aggregate retained on 1.7 mm IS sieve, because we may not be able to weigh all the dust particle which are passing through 1.7 mm IS sieve. So we will weigh the aggregate retained on 1.7 mm IS sieve, and we will find the aggregate passing through 1.7 mm by subtracting that from original weight of the sample. So loss in weight will be W1 minus W2. So our W1 was 5000 gram, and we will get the weight W2 from the collected aggregate, and we will find out the weight of aggregate passing through 1.7 mm IS sieve, and aberration value is W1 minus W2 divided by W1 into 100. This is the aberration value. So we will obtain the result, that is Los Angeles aberration value in percentage. Since it is giving us aberration as well as impact together, this test is more acceptable. And depending upon the numerical value you obtain, suitable aggregates for different road constructions can be judged as per the IRC specification given below. For waterborne macadam sub-base course, we may require aggregate aberration value of maximum 60%. That is 60% can be put into the powder. Okay, so this can be provided for waterborne macadam sub-base course alone. And for waterborne macadam base course with bituminous surfacing, maximum aberration value should be limited to 50. And bituminous borne macadam, the maximum aberration value should be limited to 50%. And for waterborne macadam surface course, it should be 40, because surface is the place where wear and tear will occur. So we have to limit the aberration value to 40. And for bituminous concrete surface course, it is 30. So we may require high quality aggregate aberration aggregates for surface course, since surface course is a course which undergo wear and tear directly from the vehicles. Okay. Thank you.